look around you right now. What do you see? A pencil, a book, maybe a cell phone? One thing that all these things have in common is the fact that they are all made up of atoms. I just blew your mind, right? Anyway, what people don't give atoms enough credit for is the amount of raw power each individual one of the small building blocks of our universe contains. Take a water atom, for example. If you were to split one water atom into its base elements, you would see one oxygen atom and two hydrogen atoms. For the sake of this video, we will be looking at only the hydrogen atoms. We can examine how much power each one has and how to extract that power using a concept known as nuclear fusion. Nuclear fusion is the act of taking two light atom nuclei and then pushing them together under extreme force to result in a single heavier atom with immense energy payoff. Let me put that into perspective for you. See, suns and stars will actually use fusion as a source of power to maintain themselves. Now, if you were to actually use fusion as humans, we can maintain that kind of energy and power ourselves with almost no impact to the environment on a whole. Before we go into that, however, there are a few terms that I should explain, just so this video doesn't sound like it's in another language. Isotope. An isotope is a variation of an element that has the same number of protons but a different number of neutrons. The chemical properties of these isotopes are the same, making them able to be classified as their element. Kinda like if you picture two people, one of them with blonde hair and one of them with brown. They're both humans, however, they have a notable difference in how they're made up. Deuterium. A hydrogen isotope with one proton and one neutron. Tritium. A hydrogen isotope with one proton and two neutrons. So, first question. What actually happens during fusion? Well, in our example, it's when two hydrogen isotopes are subjected to so much pressure that they combine into a helium atom. The reason that fusion gives off energy can be explained by Einstein's E equals mc squared, which states that energy in joules equals the amount of mass in an object in kilograms multiplied by the speed of light in meters per second squared. I know that's a mouthful, but let me elaborate a little bit further. Say I take two hydrogen isotopes and weigh them together. Then, if I apply nuclear fusion to both of those atoms and weigh that end result, the total mass of the two atoms apart will be ever so slightly more heavy than the fused atom. That's where the equation comes in. The weight that was removed was converted to energy, which is equal to that amount of weight times the speed of light squared. So there you have it. Fusion is the act of taking two light nuclei and combining them into one heavier nucleus, and in the meantime, some of that matter gets turned into pure energy in the form of heat. With that, I've been Joe Burke. Thank you so much for watching, and I hope I was able to make a few ends meet about nuclear fusion.